Our next is David Friedlander. He works with Stan Franklin on LIDA and the theory of mind. And the only thing I can't resist this, is your system ever going to say, nice, but could we just have a nice game of chess?
That would not make a lot of sense in this context.
Good. Okay. This is the microphone. I'm going to talk about LIDA and the theory of mind by Stan Franklin and myself. LIDA is a computer model of human cognition developed by Stan Franklin at the University of Memphis. It's based on current research in psychology, neuroscience, cognitive science, and artificial intelligence. The architecture is too complex to explain in 10 minutes, so I'm only going to present the components necessary for a theory of mind. The theory of mind states that we ascribe minds and mental states to other individuals, even though we only have direct evidence of our own mental states. One can argue that a theory of mind would be necessary for an artificial general intelligence so that it could reason effectively about, learn from, and communicate with other intelligent agents. Now, we used a primate experiment for an example, even though we're more concerned about humans because it was simple. It's illustrated in slide 2. The experimenters approached a monkey with 2 containers. There was a noisy container that had bells on the lid and body, and a silent container that had bells with the clappers removed. A grate was placed in each container, and this action caused noise for the first container, but not the second. In one set of experiments, the experimenters faced the ground, and in the second set, they faced the monkey. When the experimenters faced the ground, the monkey preferentially chose the silent container, but when they faced the containers, the monkey chose at random. And the researchers concluded that these data were evidence that the monkeys had a mental model of the human experimenters who were considered potential rivals for the food. This is a very highly simplified diagram of LIDA. During each cognitive cycle, the agent first makes sense of its current situation and then decides what portion of this situation is in most need of attention. This portion is broadcast to all components of the model, and then the agent chooses an appropriate action and executes it. In the LIDA model, pre-processed sensory data are fed into perceptual memory, which is implemented as a hybrid neural semantic network. Nodes represent concepts and links represent relationships as in a semantic network, but nodes are excited by activation passing as in a neural network. There are 4 root concepts needed for the theory of mind in the experiment: actions, relationship, goals, and objects. The slide shows a representation for relationships only. During each cycle, the excited nodes and the links connecting them are instantiated in a component of the model called the workspace. The instantiated structure is called the percept because it's what the agent has perceived. The workspace contains recent percepts that haven't decayed away and related associations for memory. The agent's model of the current situation is assembled from them. During each cycle, the situation is updated using the current percept and its associations. The creation of models from percepts and memories is done by structure building codelets. Codelets are independent software agents. They're small and simple, and they perform most of the actions in LIDA by working in combination. This figure shows what part of the workspace might look like after a number of cognitive cycles, after the experimenters have put the grapes in the containers. These workspace structures compete for attention, and the winner is copied to an area of the model called the focus of attention, which is analogous to consciousness in humans. The information in the focus of attention is then broadcast globally to all areas of the model. But the primary recipient of the information is procedural memory, which stores templates of possible actions, including their contexts and possible results. Let us assume that one of the two structures in this slide has made it to the focus of attention. If the monkey is hungry or likes grapes, a template for eating may be activated in procedural memory when it sees the grapes and instantiated in the workspace for evaluation. If the top structure of the previous slide was broadcast, the template will bind to grape and noisy container. This is labeled as plan 1. If the bottom structure was broadcast, then the template will bind to grape and solid container, which is labeled plan 2. Any objections to the monkey's plan would likely concern possible interference by the human. The monkey reasons about what the human would know about potential actions the monkey could take. This is the essence of the theory of mind. The monkey will consider the first plan that comes to mind for a period of time, and if no objections occur, it will carry out that plan. If there's an objection, the monkey will look for another plan. And if it can't find a best plan, there are various tie-breaking mechanisms which are described in the paper. I don't have time to go into them during the talk. Now, this slide shows 2 of 5 structure-building codelets that the monkey might use in evaluating the plans. The codelets are represented as graphs with some nodes containing variables whose name starts with a question mark. The variables can bind to concept nodes in a workspace that are of the same type as the variables. The subgraph on the left is the context for the codelet. The middle link contains a probability estimate that the event corresponding to the structure on the right will occur in the context of the left. Codelets 1 and 2 state that when the human is facing the monkey, they will see and therefore know of the monkey's actions. Codelets 3 and 4 state that when humans hear monkeys' actions, they will know about them. And codelet 5 states that rivals may try to interfere with each other's actions if they know about them. Now, codelets 3, 4, and 5 combine with the structures in the workspace to raise an objection to plan 1 for either experiment. Because if the experimenter uses the noisy container, then if the monkey uses the noisy container, the experimenter will know about it. On the other hand, codelets 1, 2, and 5 combine with workspace structure to create an objection to plan 2 only in experiment 2 when the experimenter is facing the monkey. So in experiment 2, both plans have objections, and a tie-breaking mechanism would need to be used to determine what to do. In experiment 1, this objection will not occur for plan 1, and the monkey will prefer the silent container. The LIDA model can therefore explain the results of the primate experiment qualitatively in a psychologically realistic way in terms of a theory of mind. The monkey's actions depend on where the experimenters were facing. They were derived from a representation of the experimenter's mental state and the monkey's belief in the experimenter's potential to interfere with their plans. Now, if I have a little time left, I'd like to also state that I believe we experience the theory of mind viscerally in a form of empathy. And as a test for intelligence, we can use theory of mind if we feel a theory of mind about an intelligent agent, if it's artificial, that would be one test for an intelligent agent, or at least an agent with a mind. And also, if the agent has the same feelings about us, that would be another test for an intelligent agent. Okay?
All right.
Yeah.
Thank you. 10 minutes. Great.